We will learn how to create a C language software design and run it in Linux environment on ARM processor on DE1-SoC Terasic board. Our design is like C code. This is the C code and Makefile, which is Makefile for the C code design, which is a text file that will tell the make program how to build the executable file from the source code. So make will read the make file and know which compiler to use. In this case, this is the compiler, cross compiler, and which files to compile, which is in this case is the main file, main C file, and how to link them into an executable file. So beside DE1-SoC board, the following softwares and hardwares are required. So we'll need Microsoft Windows computer with USB port, and maybe we might need Ethernet port, depend on which way we're gonna transfer the executable file to the board. And we might need, if we need the we might need Ethernet router, and we will need Altera SoC EDS embedded design software installed, and we need those softwares also, and we will need a bootable SD card with Linux system. I already burned the Linux operating system on the SD card. So in our project, we will run the compiled C code on Linux environment on DE1-SoC to control different connected peripherals to the HPS on Terasic board. So this is the HPS side of the Terasic board, and those the peripherals connected to the HPS, to the processor system. And specifically, we will control the operation of this LED here, and scan the functionality of this switch button by observing the LED. So when we push this button, if the button is like working good, we will see LED blinking here. So again, this is the C code, and on CPU, the CPU in Linux doesn't directly use physical address. Instead, it uses virtual addresses that are translated to physical address by the memory management system. So what we will do, we will get this virtual address here, and we will pass those physical address here, and we will get out the virtual address through this function map. So we can use the virtual base here through the execution of this code. So here we will set this piece of virtual addresses as like this is for this is piece of addresses is for general purpose input output, and we will use this to assign each of those pins to either input or output. And one like for the output section, we will do this loop here. So we will set one of the pins here as LED, make it turned on and off for 2 times, and then we will scan the input here, and if it's changed, we will observe the LED if it's turned on. Here is the Altera embedded design suite. So we will run this shell, so we can compile the this design here. So those two files should be in the same folder, and we should go we should change the directory of this shell to this location. So cd so we'll need to go to this directory, and we can do just write make, and we can see here we generate the executable file. And this file we need to use like the USB stick, so we can transfer it to the DE1-SoC board, and we can run it there. So this is the board, Terasic board, and as we can see here, this is the SD card. So the Linux system is loaded on this SD card, and this is the USB. So the executable file here in the this USB, and in order to get the Linux operating system booted from this SD card, we need to set the switches, those DIP switches on the back of the board in this configuration. So I'm gonna turn the board on. As we can see here, we're gonna see it's booted, the Linux operating system. So we will need to log in as a root, and now we will need to detect the USB drive. To detect the USB drive, we will write fdisk L. Disk So as we can see here, we can see the USB drive, and now the next step, we will need to do make a directory we'll need to mount create a mount point between the USB drive and the board. So to do that, we will need to make a directory first. So mk directory, we will name it media USB drive. And we will mount this the USB drive to the directory that we are already create. So mount device is DE1 media USB drive, and the next step, we will need to go to this directory. So go to cd media USB drive. So as we can see here, this is the our file here, HPS GPIO, and so we can run it here. So it's running. So we will run it one more time. This LED should blink twice, and so now we will check the functionality of these button. So when we push this, should be blinking.